Hello students, you are welcome to Prepclass Tutors. My name is Mr. Chima and I'll be taking you on chemistry. So students, what's happening? I'm so happy today. I'm just so happy because I don't know when you are receiving this, but as at now that I'm preparing this, or as at now that I'm doing this recording, or as at now that I'm doing this video with you guys, today is the last day of December 2020 and I'm just so happy. I'm so happy to see the end of this year. It has been a very wonderful year for all of us. For some people, it has been a very tough one, from COVID-19 to stay at home, blah blah blah, and many other things like that. But all the same, we are so happy to see the last day of December 2020. So now let's go straight to the point as we will continue with our exam solving questions on chemistry, WAEC 2020. I've taken you guys on questions 1 to 5. So now quickly let us look at questions 6 to 10 of this section. Alright, now let's start. So before we start, as usual, I want you all to try to like all our videos. Try as much as possible to subscribe to our YouTube channel. Like our videos so that you'll be getting more and more fantastic and very educational videos on not only chemistry but every other subject you wish to learn with Prepclass tutors. So now let us continue. Question number 6. What mass of silver deposited, or what mass of silver rather is deposited when 24,125 coulombs of electricity is passed through a solution of silver salt? What mass of silver is deposited when 24,125 coulombs of electricity is passed through a solution of silver salt? And you can see that I've given you the molar mass of silver, which is 108. They've given you the electrochemical equivalent. 1 Faraday, 1F is equals to 96500 coulombs. How do you approach this kind of question? Okay, let us see. Now look at what we did here, or look at what I did here. I said solution. First of all, there's a formula I like using. I can say I invented this formula. You can see there, M equals EIT over Farad. It's very simple. Whenever I give you a question on electrolysis, I would really like you to always use this formula. It's a very good one. M equals EIT all over Farad. Where M is unknown here. This M now represents the mass. Remember, Faraday's first law of electrolysis states that what? The mass of a substance deposited during electrolysis is directly proportional to the quantity of what? Electricity that passed through the electrolyte. So that this M here represents the mass of the silver that is deposited. The E here is the electrochemical equivalent, but in chemistry here we call it molar mass. The molar mass of the silver, which is what? 108. You can see it's already in the question. And Q here is the quantity of electricity. Remember that quantity of electricity Q is given as what? IT. So Q is this IT here is representing your Q. In your SS1 chemistry, quantity of electricity is equal to what? I times T. I represent the what? Current of electricity in amperes, and T is the time in seconds. So that's why I use this M is EIT over Farad. So in a nutshell, I can say M is equals to EQ over Farad. That's M is equals to molar mass times quantity of electricity, which is current times time, or Q, given us in coulombs all over Farad. So when you bring that, substitute the values, you have M equals 108 times the quantity of electricity. You can see it here, 24,125. So 24,125 divided by 1F, that's 1 times 96500 coulombs. Take notes here. This F here as the Farad, it also directly affects the oxidation state of this element deposited. If I want to write the symbol for silver ion, is Ag plus. That's for silver ion. So that means that silver has an oxidation state of +1. So because silver has an oxidation state of +1, Ag plus, I I'll have only 1 times 96500 coulombs. If it were to be iron, for example Fe, and let's say the iron there has iron has 2 oxidation states, +2 +3. If it is +3, for example, I'll have 3 times this. If it's +2, I have 2 times this. I believe you understand what I'm trying to say. If you're looking at aluminium, for example, you know, aluminium Al has an oxidation of +3, Al 3+, so it will become 3 times this 96500 coulombs. But because this silver is +1, so that becomes 1 times 96500 coulombs. So you have M equals this divided by 1 times that is that 108 times 24125 will give you 2605,500 when you use your calculator. Then divide that, M becomes what? 27 grams. Very simple, very interesting. Just apply this formula. M is equals to EIT over farad. Straightforward, and your answer will just what? Come on. I believe you understand that, and you find that very what? Interesting. Let's move. So what's now the correct option? The correct option is what? D. You can see here they've given us, let's go back. You can see they give us the first one, 432 gram, 108 gram, 554 gram, 27 gram, and after we finish solving it, we got our answer as 27 grams. So the correct answer here is 27 gram. Okay, question number 7. Question number 7. Question number 7 says, equal masses of calcium triisocarbonate 4 were added to dilute hydrochloric acid at the temperature specified. Under which of the following conditions would the reaction be slowest? Under which of the following conditions would the reaction be slowest? A, they say zinc calcium triisocarbonate 4 chips at 20 degrees Celsius. B, zinc calcium triisocarbonate 4 chips at 40 degrees Celsius. C, zinc calcium triisocarbonate 4 powder at this, and D, zinc calcium triisocarbonate 4 powder at 40 degrees Celsius. Now, how will you approach this question? They've told us that equal mass of calcium triisocarbonate 4 were added to dilute hydrochloric acid. Of course, in this kind of reaction, triisocarbonate 4 will react with an acid to give a salt, water, and a carbon 4 oxide. But they are not asking you of the reactants, or they are not asking you of the product that will be formed. They are asking you, the question is directly related to rates of chemical reaction. So they are asking you which of them would the chemical reaction be slowest. Take notes, slowest. Take notes, slowest. Remember that what increase in temperature increases the rate of a chemical reaction. So you will never choose any option of 40 degrees Celsius. So the reaction that will be slowest will be a reaction in which the temperature is lower, which is 20 degrees Celsius. So we are looking at either option A or option C. That's number 1. Number 2, they've told us chips and powder. Chips simply means, like a stony form. Powder is the fine, smooth form. And remember, we say that what there is a reason that says that what nature of the reactants affect the rate of a chemical reaction. If the reactants are in chips form, the reaction may be slower. But the reactants are in powdered fine form, the reaction will be what? Fastest. So that means that in this case, whereby the reaction is in the question number C will not be a good option, because there the reactants, calcium triisocarbonate 4 is in powdered form. It will be very fast. So where it will be slower will where the reaction will be in the chips form. So the best choice now is option what? A, where the calcium triisocarbonate 4 is in chips form and at 20 degrees Celsius. So you can see the answer here. Option A is the best choice, where the calcium triisocarbonate 4 is in chips form and at 20 degrees Celsius. Very simple, very, very simple. Okay, let us look at question number 8. The high solubility of ethanol in water is due to dash. The high solubility of ethanol in water is due to A, is it slow boiling point? B, is it slow freezing point? D, C, is it slow covalent point? Or D, is it this hydrogen bonding? The high solubility. Now, ethanol, let us look at what it is. See, look at the chemical formula I gave you here. Can you see it? That ethanol is what? C2H5OH. You can see that ethanol has this hydroxyl group OH. ethanol has this hydroxyl group OH. Water at the same time too, if water should dissociate H2O, dissociate into hydrogen and OH minus, you see that water too has that same hydroxyl group. And you can see that the bond in water is a hydrogen bonding with the hydroxyl group. So the main reason why ethanol is very soluble in water is because this OH minus from the ethanol can easily bond with the hydrogen ion that is in the water. So the best choice is the what? The hydrogen bonding. So it's the hydrogen bonding between what? The molecules of ethanol that makes it to be very soluble in water. So the best choice is answer or option D. So option D is the best choice, hydrogen bonding. So it's the hydrogen bonding that ethanol has in its molecule that makes it to be what? Very soluble in water. I believe you understand that. It's very simple. It's very, very simple. Question number 9. Which of the following metals react slowly with cold water? Which of the following metals react slowly with cold water? We have option A, calcium, option B, silver, option C, iron, option D, potassium. Which of the following chemicals react, which of the following metals rather react slowly with cold water? Not hot water, but cold water. So now, you must know that a metal that reacts slowly with cold water will be a metal that is at least very reactive, but though not very reactive. Because a metal that is very reactive will react what? Violently with cold water, or what? Vigorously with cold water. But since this metal is able to react at least with cold water, maybe to give an oxide or a hydroxide, that tells you that this metal will be a reactive metal. I believe you understand that. So now let us look. Look at the statement I wrote here. Which of the following metals react slowly with cold water? I first of all say, let us look at them one after the other. Calcium, Ca. So I said calcium reacts slowly with cold water and vigorously with hot water. So I want us to consider the nature of each of these metals, the way they react. Calcium reacts slowly with cold water and but vigorously with hot water. Silver, Ag. Do not mind the noise you hear in the background. Let's just continue. Silver, Ag. Silver do not react with water at all. Now you must know that silver and gold are usually found in the earth's crust in their free state, because they are the least reactive metals. They do not react with any other. They are not very, very reactive. So in most cases we find them in their pure form. So silver do not react with water. That is it. Iron, Fe. Iron reacts with steam at red heat. So for iron to react with water, first, it must be red hot. 2, the water must be in the gaseous form, which is steam. So iron and aluminium, in most cases, they react with water at red heat. K, potassium. Potassium reacts violently with cold water. So potassium and sodium, they are the most reactive. They are among the most reactive metals. Remember that they belong to group 1 of the periodic table. So potassium, K, and sodium react violently with water. So if you look at here now, the best choice will be calcium, because out of all of them, it is only calcium that reacts slowly with cold water. Silver do not react at all. Iron must react when it is red hot, and it will react with steam, while potassium will react violently with cold water. So you can see the best choice. I choose A as your answer. So the best answer there is A, calcium. Calcium reacts slowly with cold water. Number 10. Which of the following pairs of properties of alkaline metals decreases down the group? Which of the following pairs of properties of alkali metals decreases down the group? They are asking you each of all these properties. Which one decreases down the group? A, is it first ionization energy and reactivity? B, is it melting point and atomic reactivity? Remember that atomic reactivity is something as reactivity. B, is it reactivity and electronegativity? and D is the first ionization energy and melting point. So they are now asking us the one or the property of the elements that decreases down the group. So let us look at them one after the other. Look at what I said here. I said that ionization energy decreases down the group. This means that reactivity will increase down the group. First of all, what is ionization energy? Ionization energy can be defined as the energy that is required to remove an electron from an atom to make it an ion with a net positive charge. That's what ionization energy is. Very simple. The energy required to remove an electron from an atom to make it an ion with a net positive charge. So that kind of energy, as you see, it usually decreases down the group. It usually will decrease down the group, but increase across the period. And so it usually increase across the period. Because the energy that is required to remove an electron from sodium, that is in group 1, is higher than the energy that is required to remove 2 electrons from calcium, that is in group 2. Is higher than the energy that is required to remove 3 electrons from aluminium, that is in group 3. And of course, almost higher impossible to remove 4 electrons from carbon, that is in group 4. So because of that, ionization energy increases across the group, but increases across the period rather, but decreases down the group. So if ionization energy decreases down the group, it simply means that the reactivity of the elements will be higher. So if you look at the element down the group, they are much more reactive as you go down the group. So ionization energy decreases down the group, but reactivity increases down the group. Now I said here that the more reactive metals, the more the reactivity of the metals, the lower will be its melting and boiling point. Do you understand? So metals that are more reactive usually have lower melting and boiling point because they can easily dissociate, they can easily react. But the ones that are not too reactive, their boiling point is usually very, very high. You can't compare the boiling point of iron with the boiling point of sodium. I believe you understand me. So as you go down the group, ionization energy decreases, reactivity increases, melting and boiling point decreases. As you go down the group, ionization energy does what? Decreases, reactivity increases, but melting and boiling point decrease. So your best choice will be D, first ionization energy and melting point, because ionization energy decreases down the group and melting and boiling point also decreases down the group. Okay students, I believe you enjoyed this section with chemistry that we just had about 5 questions number 6 to 10. So please do not forget to always like our videos, subscribe to our YouTube channel, and you can always join us on WhatsApp to get more engaging video. So till we meet again, bye, and my name remains Mr. Chima, your chemistry tutor. Do take care of yourself. Cheers.